Example of a piecewise function. Oh, sorry. Did you hit it? You good? Okay. 47 is an example of a piecewise function. I know that because it's got the function name g of x, and it's equal to more than one expression. The way the piecewise function works, if you were to make a chart, an x and y chart to graph this thing, if your x's were less than -1, then you would plug those values into the top equation. For all values that are greater than 0, you would plug into the bottom equation. So depending on what the value of x is, that's going to determine which expression you use. Okay? Which means this question is asking what is the domain of this piecewise function. The domain is always found over here on the right hand side. The domain of piecewise functions is always found on the right hand side over here. So this is our domain. It's all x is less than -1, and it also includes the x is greater than 0. Okay, so if we write that out in interval notation, for example, that would be 47. The domain would be from -infinity all the way up to -1, union with 0 all the way up to infinity. Everybody okay with that? So not only I want you to know how to find the domain of a function, of a piecewise function, but be able to identify it too. That's key. Identify a piecewise function compared to a function that's not a piecewise function. Okay, so 48. I don't know. Who's got the sign-in sheet? Okay. I just wanted to get on the camera, don't lie.
Yeah.
Alright, 48. Find the domain. That's another piecewise function. Where would I find the domain? It's on the right hand side. It's this, all this stuff right here. So I got x less than or equal to -1. I've got all the x's in between -1 and 1, not including either one. And then I've got all the x's greater than or equal to 1. So if you were to put all those on a number line, what numbers are represented? Or are there any numbers not represented? Less than or equal to -1. This is greater than or equal to 1. This is all those numbers in between. So what's the domain of this? All real numbers, right? Everybody okay with that?
Yeah.
Questions on that? Yes?
So like if we were to put those values, all real numbers. Alright, yeah.
Yeah. So it would either be all real numbers, you might see it like this, or you might see it in interval notation like this, right? Either one.
So it's just you're always looking at the thing on the right, like the greater than or less than on the right, and finding out what numbers are involved in and then writing them.
If they're asking for the domain.
If they're out there.
Okay.
Awesome.
Okay, 49. Give the fifth term of the expansion. A minus 5b to the 6th power. They just expanded it all out, but they just want us to give the fifth term. Okay? What was my advice when expanding something like this out? Yes, sir?
Use x and y.
And just make it simpler, right?
Yes, sir.
So my advice would be to expand x minus y to the 6th power, right?
Yes, sir.
And then substitute in an a for your x's and a 5b for your y, right?
Yes, sir.
Alright, so if we expand this out, we get x to the 6th minus 6x to the 5th y plus 15 x to the 4th y squared minus 20 x cubed y cubed plus 60 divided by 4 is 15 x squared y to the 4th. Do I need to keep going?
No.
No, because this is really the only thing they want. That's the 5th term. 1, 2, 3, 4, 5. Right? So, and now I need to substitute. So I've got, it'll be 15 a squared and then 5b to the 4th power. Everybody okay with that?
Yeah, so.
Wait, what? How do you like get the 15 and the 20 again? Like, what was this trick
The
thing?
shortcut,
Yeah.
take the coefficient. Well, this will start over here. It's a 1, right?
Mhm.
I know it always starts out with 1, so you can do that.
Yeah.
Multiply it by the first exponent. So 1 times 6 gives us 6. And then divide that number by which term that it is. This is the first term. So 1 times 6 is 6, divided by 1 gives me 6. 6 times 5 is 30, divided by 2 gives me 15.
Okay.
15 times 4 is 60, divided by 3, 20. Okay?
Okay.
Or you can draw the tree out. Yes?
Is it okay if we write on this review?
Sure.
Okay. Yes, sir.
My advice was no. But that's your review, I don't want it back.
Okay, yes, sir.
Wait. Never mind.
My hopes were that you would do the review on a separate sheet of paper, the whole thing. Figure out what you don't know, learn it, whatever. Then take the blank review and do that as a practice test.
That's a good idea.
And then you can check it with your work that you did, mark the ones wrong, and you go, oh, those are the ones I need to go study. And then if you still have a blank review again, take it again as a practice test. If you follow that process, eventually you'll get 100 on that practice test, and then you'd be ready to take the exam.
You can check your answers on YouTube too.
Hey.
Correct. Okay, so fortunately this is the calculator portion. Does anybody know what 5 to the 4th power is?
Isn't it?
625.
25 times 15?
9,375.
9,375 a squared b to the 4th.
There.
There is our 5th term. Questions on 49? Okay. 50. What is the approximate solution? This is the calculator portion. I would just graph it, find out where it crosses the x-axis. If they're going to choose a calculator, why not, right? All right, so on y1, put the left-hand side of the equation. And on y2, make sure you put the right-hand side of the equation. Graph it.
Wait, what do you put Y2?
On y2, put the right-hand side of the equation.
Oh.
0, right? All right, so graph it, and you'll find the solutions of where it crosses the x-axis. So we need to find the intersection point. That's why we had to put something on y2. Y equals 0 is the x-axis. So, second calc, intersection. And let's find the one on the left first, just because that's how we read, left to right. So just move the cursor close to that intersection point and then hit enter 3 times. It looks like x is equal to a negative 2 does it say? 2.686.
Yes, sir.
And then second calc, intersect, move the cursor close to the other intersection point and hit enter 3 times. We get x is equal to 0.186. So those 2 answers. Questions?